Hello, everyone. My name is Brandon Kovacs. Really excited to be here today. I did wake up today with a slight cold. I'm waiting for the day cold to kick in, so just bear with me. But I promise I'll do my best. So let's get started. As I said, my name is Brandon Kovacs. I've been into cybersecurity kind of my entire life. Started off when I was like 14, working on a blue team, doing like real-time network defense and attack mitigation for really large financial institutions. And fast forward today, I currently work as a senior red team consultant at offensive security firm Bishop Fox, where, as I like to phrase it, I get to do the really fun stuff. So why are we here today? As I said, I work on a red team, and part of being a red teamer is that ability to emulate tactics, techniques, procedures. I've always believed that the best defense requires great offense, and in this world, it really requires you to understand how things work, right? And that's the intention of today's session. We're going to start off with a very high-level overview of AI terminology and concepts. I'm trying to keep the content balanced, technical, yet accessible for people who've never been introduced to this before, can still grasp it without having it go over your head. Then we're going to talk about how deepfake models are created, both video and audio, using strictly open source tooling that's available on like GitHub. Then we'll talk about operational use cases, providing real life examples of various assessments that we've run that have incorporated elements of deepfake video and audio. And then finally, time permitting, we'll then do a live demonstration. So let's begin. So yeah, there's a quote that everyone's probably familiar with, that you can be whatever you want when you grow up, and that couldn't be more true today, especially with the rise of artificial intelligence. It's really shaping the future of social engineering and allowing threat actors to pursue all sorts of attacks whose tactics, techniques, procedures include elements of deepfake video, which is video trained on public information and then used in like video calls to perform social engineering. Voice cloning, taking public information of a subject or target and essentially copying their voice to where as you talk into a microphone, that source subject's speech comes out with a remarkable degree of accuracy. And although it's not in the scope of today's talk, it's enabling people to do things such as generating phishing emails, and even conducting phishing at scale using tactics such as RAG pipelines to look at large data breaches and compose emails on a very hyper-personalized level and at scale. And also, as we saw last year during political campaigns, voice cloning and phishing has been used at scale to do things such as political candidate impersonations and used in conjunction with robo-dialers to spread disinformation. So although it can be used for good, it can have some very serious security implications and ethical considerations that we'll talk about today. So let's talk about the evolution of, the evolution of deepfake attacks. Starting in 2019, we had the first publicly known voice cloning incident in which the CEO of a bank in England had their voice cloned. Long story short, $250,000 lost. Fast forward to 2020, there was a finance professional at a multinational firm in the United Arab Emirates, the UAE. They had their voice cloned and they lost $35 million. Fast forward to 2023, I guess I can say it here because we're in the US. You had threat actors from Iran targeting television networks and streaming providers to create deepfake videos of news anchors and then disseminate them across those platforms to spread misinformation. And then lastly, what got me really interested in this was last year, the first real-time deepfake incident, at least that we know of, right? In which a finance worker at a multinational firm called Arup out in Southeast Asia thought he was on a live video call on Zoom with the chief financial officer of his company. And long story short, he was instructed to send a $25 million wire transfer, which he did because his boss was telling him what to do on a video call. And it turns out it wasn't actually his boss, it was a real-time deepfake. And when that happened, I had 3 reactions. That's crazy, that sucks, but most importantly, how do they do it, right? Because ever since then, we've had a lot of clients of the company I work for reaching out and asking us, like, hey, can you clone our CEO, or can you clone so-and-so and start to like run engagements and do social engineering with it? Turns out we can. So before we dive into the meat of everything, I think it's important to establish a baseline of terminology. So at its core, a model is essentially like an algorithm, right? That's trained on a data set. And through a process known as training, it's learned to recognize patterns and create a series of predictions, right? And then finally, through the process of called inferencing, we take that trained model, we provide it new unseen data, and then it makes the decision and provides an output based on training the models themselves. It doesn't matter what type of model you're creating, whether it's a text model, a photo, vision model, an audio model such as a voice clone. The type of model that you create will determine what type of data is used to compose the data set. Typically that data set will have to be processed ahead of training. You have to clean it, format it, label it, and those processes and those substeps will look different based on the type of model you're trying to create. So for example, let's say you're creating a vision model, right? That can detect a hot dog versus not a hot dog, right? You're gonna provide a data set of hot dogs and you're gonna label it hot dog, not a hot dog, right? So that way, when you're training with whatever architecture you're using, it could then look at that data and then create a series of predictions and create this trained model. Finally, once you have that trained model, you then do the inferencing, which is probably the step most people here are familiar with. It's kind of where all the magic happens. So for example, ChatGPT was trained on a large corpus of text. You ask it a question, it uses the information it was trained upon to then generate a response. The idea here is that you provide new unseen data to that model, and depending on the type of model and whatever task it was trained to perform, it then provides an output. Let's say we have a natural language processing model that can look at a string of text and do like sentiment analysis, positive or negative, or a classification model that can look at a bunch of text and say this is spam or not spam. The idea here is that you have a model that's trained to do a specific function, you provide it input, and it gives us output. So now the really fun stuff, but important disclaimer. It shouldn't be said, but we have to say it, right? The act of cloning someone and like using their likeness has very serious ethical considerations. You shouldn't clone anyone without their consent. This presentation and the model I'm going to demonstrate later on strictly adheres to these concepts. So let's talk about voice cloning. Voice cloning can be done using an open source tool called retrieval voice conversion, also known as RVC. It's trained on use audio as a data set to train the model. And then the inferencing allows you to supply it with audio to do audio to audio conversion. So for example, you talk into a microphone, it takes that audio buffer, throws it against the model, and then out comes the person's voice who was trained upon with a very remarkable degree of accuracy, as you're gonna see in the demonstration. The process of training the voice model is pretty straightforward, and it looks very similar to what I showed you. However, those sub-steps vary, and we'll go into detail of what that looks like. But essentially, like I said, you're gonna use audio files, so like a WAV, MP3, etc. We're gonna clean, splice, convert, transcribe, and label the data, and we'll go through that in a moment. The training process, we're gonna train a model and also something known as the feature index, which will then give us that trained model. So everyone say hello to my friend Chris. For this example, we had him read from a script. It had 300 lines that are all phonetically diverse, just so we can get a nice wide range of the vocabulary, in the English language at least. Each line was around 5 to 10 seconds in length and was recorded with like a high quality microphone and WAV format. You don't really need to use this. You could also, if like you're doing an engagement and you're trying to target like a public figure, like the CEO of a company, if you think about it, if you're a publicly traded company, you have earnings calls that you have to be on every quarter, interviews, press, podcasts, you name it. So you can either record it yourself or you can source it publicly. The next step is the actual preparation of the data itself. This is where the cleaning, splicing comes into. So for example, if the speech has like, popping like this, any sort of background noises, any sort of large gaps in the audio, you're gonna wanna clean that up and remove it just so you have a nice clean data set of just spoken speech. This can be done using like a paid tool such as Adobe Audition, which is my preference just because you can automate the process of editing 300 clips at once, or you can do the free version, Audacity, which will take a lot longer, but it's there. Next, we undergo a process called labeling, where in the context of voice models, we're transcribing, right? We're creating a mapping between the file name and what was said. And this isn't really required for RVC, but it is required for other vocal models, so I just wanted to throw it in there just so you're familiar with it. But the idea is that the trainer will look at this and then look at all the files and be able to then emulate that once, in the future, once the model is trained. Training itself used a RVC dashboard, and I'll go through the parameters of what these mean. So the first thing we're doing, we're setting all the parameters. So we're setting the sample rate to 40K. We're not enabling pitch guidance. Pitch guidance is only required when you're training a model for singing. We're maximizing the number of CPU processes. That way the trainer can process the data set rather quickly. We're going to train it to 1,000 epochs. So an epoch is essentially a complete pass of the data set. So we're going to look at it 1,000 times. And every 50 times, we're going to save a checkpoint of wherever the model is at that point in time. The idea is, at the end of training, I'm going to have a bunch of checkpoints to go through and pick and choose which one sounds the best. I'm going to set the batch size to 40. I'm maximizing it. The batch size represents how much data, when it's doing a pass of the data set, how much data it looks at a time. And your batch size is really determined based upon your compute and what hardware you have available. If you have like an NVIDIA 4090 or 5090 with like 24 to 32 gigabytes of VRAM, you can maximize that batch size to its greatest value. If you don't have that much compute available, you obviously have to adjust it accordingly. Otherwise, the GPU will run out of memory. And then training the data set itself is really straightforward. It's stupid easy. You push 4 buttons. Once you have the parameter set, you push process data, feature extraction, train feature index, and then train the model. Depending on how much data you provide and depending on how much compute you have available, training a model can take anywhere from like 2 hours up to 24 hours. Really depends on what you're working with. Once we have the final result of this will then be the trained vocal model, which is represented as a path file, and then the feature index represented as an index file. And then from there, we can use something called the voice changer to inference our model against a WAV file or an audio buffer. So we can then do audio to audio conversion of the of speakers, such as myself, and then have my voice output as whoever the model was trained upon. And once we have that set up, it allows you to do some really unique use cases. So for example, I can take my trained model and an audio buffer to inference it against my voice changer. From my voice changer, I have the spoken speech coming out of the person's talking, outputting, and then I'm feeding that output to the input of a virtual audio cable. The output of the virtual audio cable is then set as the microphone input on teleconferencing apps. So for example, Zoom, Teams, Skype, the FaceTime web dashboard. You can then essentially use the voice changer to then talk and have an actual conversation with someone. You could also hook this up to a soft phone and then connect it to a telephone network to then place phone calls, right? So there's some really interesting use cases for this, especially when we're doing engagements, and which we'll dive into in a moment. And I'll show you what the voice changer interface looks like. I made sure to get some screen recordings just in case things don't work, but here. So here we're taking our trained model and we're just applying it to the we're uploading it to the voice changer. And everything here is running locally on Docker. I'm using like consumer grade hardware. I'm using a gaming laptop. You don't need a crazy $60,000 NVIDIA GPU to do this. I'm setting the chunk size to 1 second. That means when I'm talking, it's taking my speech and inferencing against the model in chunks of 1 second at a time. I found that gets the best results. It doesn't have as much latency. Then as I talk, oh, okay, I guess the PowerPoint doesn't have audio. That's fine. I'll show you guys in the live demo. The idea is as I talk, out comes my friend Chris's voice. Let's talk about deepfakes. Deepfakes can be created a number of ways. The most popular one on the internet right now is something called Deepfakes Lab. They're responsible for around 95% of deepfakes on the internet. At least that's what they claim on their GitHub. There is another tool out that came out last year called Deepfakes Cam, something like that. But what I found is that the frame rate isn't as high to really use this operationally. It works really well, but your FPS is only like 7 or 10 frames a second, whereas when I'm running these models through Deepfakes Lab, I'm getting around 30 frames a second at 1080p. So you can use, it has a more valid use case if you're using this operationally, right? Because you want that real-time aspect. So use Deepfakes Lab to create your Deepfakes models. The Deepfakes models use photos as the training data, and then through a process known as merging, we're doing face swapping from the source subject onto the destination. So for example, from the source being my friend Chris, and the destination mapping it onto my face. And as you can see, the process to create the model looks pretty straightforward, just looks like the voice models or any other model. However, the sub-steps obviously vary. For this, we're gonna use photos or videos, and I'll show you what that looks like in a moment. To prepare the data, we're gonna do a frame extraction, something called alignment and labeling, and then finally we're gonna train what's called a segmentation mask, which can then look at the face and recognize it, and then the model is trained upon that. The model, the training, again, we're gonna learn from the data set to do pattern recognition, and then finally output that trained model, which we can then inference. So let's talk about what each phase looks like. So the collection phase, I met up with my friend Chris. We shot around 30 minutes of footage at his house with a green screen with a professional camera. We had him look a variety of angles and facial expressions, so looking up, down, left, right. We had him talking. He's a huge Miami Dolphins fan, so he loves to wear his Miami Dolphins hat. So we captured footage of him doing all these things, but wearing the hat and not wearing the hat, and I'll explain why in a moment. And we captured the footage of not just him, but myself too. From there, out of the videos that we captured, if you think about it, a video is just like a set of images, right? If a video is playing at 30 frames a second, for every minute of footage, we have 1,800 frames or 1,800 pictures. So the idea here is that we're gonna first do a frame extraction of those videos of the source and destination. We're gonna pull out all the images, as you can see here. Next, we're gonna undergo a process called alignment on both the source and destination data sets, in which we look at those frames and then we just recognize, we detect, is there a face here? Yes or no? And then we look at things such as what are called facial landmarks, so the position of the eyes, my eyebrows, my nose, my mouth, the pitch and yaw of my face, how I'm rotating my head, right? So we're running this against all the thousands of images of both the source and destination. Next, we're going to label the data. Labeling the data when you're in the context of like deepfake video is called masking. So what we're doing here is defining a mask, and we're defining the facial contours of both the source and destination. So we're defining the edges where the whole face is, right? Through the forehead, through the hairline, etc., the jawline. And we're gonna do this for a number of images for both the source and destination for a variety of facial expressions and angles. Next, we train a segmentation model, which is able to then look at the labeled mask data that we supplied it, and it's able to then create a mask that is sufficient at pulling out the face, but ignoring any sort of facial obstructions. So during training, what I did, I wore Chris's Miami Dolphins hat, and I masked his hat. The reason being is that during inferencing, I want the model to recognize the hat, but don't draw a forehead over it, right, when I'm wearing it. So the idea here is that you can train for facial obstructions. Here, we train for his hat. However, if a subject has glasses, right, you would mask out the glasses during this phase, so that way when the trainer looks at it, it only pulls out the face, but ignores the glasses part, right? So that way during inferencing, as the destination, you can wear a pair of glasses, like real ones, and yeah. So next, we undergo training. So we're gonna undergo many thousand rounds of training, actually in this case, millions of rounds of training. But you can kind of see what happens as the model iterates, through all the different iterations. As we go from 1,000 to 10,000 to 100,000 to 250,000 for the source, my friend Chris, the destination, meaning myself, and then the mapping from the source onto the destination, what that looks like at that chunk in time. So as you can see, as as we iterate and the model gets better and better at trying to predict and create these predictions, the model becomes more lifelike for both the source and destination, and then that final mapping is what matters the most, right? So what's going on under the hood, per se? We're using what's called a generative adversarial network. Essentially, it's a type of architecture that is composed of two models that are competing with one another. We have what's called a generator and a discriminator. So the generator takes in random noise as input, tries to create me as a deepfake or as Chris, and then that fake image is then fed into the discriminator, which compares the fake image to a real image from the data set of images. And the idea here is that the discriminator will look at this deepfake and say, this is a fake image, or this is a real image, right? Initially, it's going to say it's fake. It's going to deny it and whatever. We update what are called our weights, and then we just go back, and we just repeat this process many, many times, thousands of times, millions of times, until finally, the generation of the deepfake images is so good to where it tricks the discriminator. The discriminator then looks at the deepfake and thinks, that's a real image. So essentially, it's a zero-sum game where this is not as accurate, and this is very accurate when we first start, right? But as the time goes on and the training goes on, this becomes less accurate, and this becomes more accurate. And once we can find that tipping or inflection point, that's the point at which the model is ready, is trained and ready to go. And this is can be seen in this time-lapse video. I'm about to start playing it in a sec. So we have the source. We're going to have this rebuilding the source. We have the destination. This will be a deepfake of the destination, it trying to predict and create me based on what it knows at that point in time. And then the last one will be the mapping from the source onto the destination and it trying to draw a deepfake of Chris using me. So as you can see right now, it's not accurate. It's just a gray box. So this is 5,000, 10,000 iterations. Here we hit the fast forward button just for the sake of brevity. But what you can see is as the model goes from 0 steps to eventually 2.5 million rounds of training, it becomes much more lifelike and realistic, and eventually is able to then trick that discriminator into then thinking it's a real image, as you can see over here. So the final result will be a deepfake model. It's known as a DFM file. Or once you have that the Deepface Lab DFM file, you're then going to use something called, Deepface Live to infer the Deepface Lab model. And the idea is you have a webcam that you supply a video buffer into the model, and then it'll do the face swapping. It'll take his face and throw it onto mine. But how can we use it? This is probably the most important part, right? So we have our video feed that we're then providing input to the Deepface Live with our model that we're inferencing, right? We're then going to take the output, whatever that preview window looks like, and then we're going to use OBS, which is free open source studio software, to capture the window from the Deepface Live, right? Showing me turning into my friend Chris. From there, we're going to use OBS to compose a series of scenes. So here I don't have a green screen, but at my home studio I do. So the idea is I can drop myself into then any virtual environment I want to be in. I can be in an office, I can be in a boardroom, I can be anyone and anywhere. The idea is I use OBS to compose those scenes. From OBS, we're then going to enable the virtual webcam functionality, which will then essentially make it a webcam, and then route that video as my camera input into my teleconferencing application. Zoom, Teams, Skype, FaceTime, whatever. So I'll show you what that process looks like. So this is using Deepface Live. I've already plugged in the model that I'm using, but essentially what we're going to do is specify the camera source. So we're going to pull in my camera that you see over there, and we're going to start driving the model. It's a 384 resolution model. Move it over, and now as I move, it's controlling the model, controlling my speech, mouth, whatever. This is cool, watch this. Next, this is what it looks like to actually compose a scene using OBS. So the first thing we're going to do is give it a background. So you're going to all be introduced to my colleague Elite's office. That's the background that she does all of her calls in. We're going to take Deepfakes Live and overlay it. We're then going to enable the chroma key filter to essentially delete the green background. The lighting wasn't the best that day, and I was in a rush to create this before I went to another conference. So you do see some like artifacts over here, just because the lighting was a little crappy in my studio. Usually this stuff isn't there, but whatever. It was for this demo. But the idea is we're then cropping it to then remove any artifacts that may be there, resizing it and dropping me into the correct spot. So it looks like I'm sitting in her office. Next, we're going to then wire the outputs from here into like a teleconferencing app. For the sake of this demo, we're going to do Zoom. We're going to enable our virtual camera over here. It's the most important step. And then we can go to any teleconferencing app and configure it appropriately. So we'll go to our Zoom settings. We'll change my camera to my OBS virtual webcam. Same thing for audio. We're now going to set the microphone input to the output coming from my virtual audio cable for the voice changer. So before we get into the demo, let's talk about how we can actually use this operationally for like offensive security engagements. A few ways. Let's pretend you're doing a red teaming engagement and you're doing an external breach, right? You have no knowledge of the client's network, whatever. You have to get in from the outside. Instead of doing like traditional vishing, right, where you call the help desk pretending to be someone, now you have the ability to sound like them too. So for example, using public information of a public figure from that company, creating a vocal model of that person, spoofing the corporate number while you're calling their help desk to look like you're calling from internally, right? Hey, this is so-and-so, I'm having trouble getting into my account, I need to do a password reset. An assumed breach scenario. For example, let's say you're under the starting point of having network access or starting on a developer system or a employee workstation. We've done assessment, and we'll get to this in a moment, where you can do an assumed breach scenario where we can leverage both the audio clone and the video deepfake model to do internal phishing over like Zoom or Teams or Skype. And then lastly, we can use deepfake video and audio models for cybersecurity training, right? Creating deepfake video and voice models of public known figures within the organization, disseminate them across the organization, in the internal intranet, whatever, to help educate employees on this matter. So let's talk about real life examples. So for example, one thing I did mention was an external breach scenario where we could leverage the voice clone to do voice vishing. Here we can do things like targeting the IT help desk of an organization to then do account manipulation. For example, resetting the password and then claiming that you just got a new phone that day and now you need to pair your iPhone as a new multi-factor authentication device. From there, as an attacker, you're able to then authenticate to whatever identity provider they're using to then do what you need to do, move laterally, and get to whatever your trophy target is that's set up for this engagement. Let's say you're doing the assumed breach scenario. You can use the deepfake voice and video model to do internal phishing, to use whatever internal teleconferencing application the client is using, Slack, video, Zoom, whatever, and start calling people within the organization to make them perform actions, actions that align with the goals of whatever the assessment is, so that way you can then move laterally and hit whatever your trophy target is. And these are all, like not making this up, these are like real life things and real life scenarios, real life examples that I can only talk about the methodology, but these are real life things we've already done and we've been doing nonstop now for the past year. And then lastly, cybersecurity training. How I said you can create deepfake audio of like the CEO talking, videos as well, distribute these across the organization, throw them on your internal dashboard, have a video of the real CEO talking, doing whatever, and then have it side by side to the fake one, and have a quiz with employees. Can you spot the deep fake? Same thing for audio too. There's some really valid use cases to help reinforce cybersecurity training. So the live demo. One moment, let me just get this set up.
I'm gonna stop. Stop. Testing 1, 2, 3. Let me hear. Oh, real. Hi, my name is Chris. Well, I'm a deepfake model created specifically for the B-Sides conference here in Tampa, Florida. To demonstrate real-time deepfake video and voice phoning capabilities. It would be fun if we had someone from the audience tries this out too. Is there anyone here that has like a beer? Yeah, with a hand. Yeah. I have something just for you. Yeah, you have to come over here.
So you get the best results when the source and destination closely resemble each other. The reason why I wanted the guy with the beard is, can you please stand in front of the camera? You may want to take your hat off because it could be an obstruction. Because we could turn him into John Wick. So, anyone else want to try? Where's a female? I got one for you. I want to make this as inclusive as possible. So for you, we're going to turn you into Meghan Merkel. Just look straight. Give it one moment. Here's a little preview. You want to see it. Do you mind switching it back to the PowerPoint? Thank you. Thank you. Okay. So I did have this screen recording as my backup, right? But I think we can just show it anyways, just to highlight the risks, especially when you start doing the deepfake in real time, as you saw now, but hooking it up to something like Zoom. So building on the example videos we saw earlier, this is kind of what it looks like. You know, me in a Zoom room, just having a conversation with myself. Again, there's no audio on the PowerPoint, so the voice isn't going to play, but you kind of just heard it over there. And that's it. This goes to my LinkedIn. So if I put a lot of stuff up there. Yeah. And I do want to take this time, if anyone has questions, I'm more than happy to answer, go into more detail as you guys need. You, sir. So I could, but it would take longer, right? I was in a rush. It's actually funny. So originally, the first model I created was of my colleague Alith, a female. She has blonde hair, whatever. And then I was set to give this talk in Dubai last year. And 3 weeks prior to me going to Dubai, I learned about an incident in which a guy from India was at the Sephora at the Dubai Mall, put on makeup, and was sentenced to 2 years in jail for impersonating a female. So I was like, it's probably not a good idea to impersonate a female in the Middle East in front of like 20,000 people. So I had to come up with a plan B. So I called my friend Chris. I'm like, hey, I need a favor. And literally the first thing he said to me was, what, you need to clone me? I was like, as a matter of fact, yes, and I got to come over tonight. We got to get this shit recorded because it's going to take around 3 weeks to train the model. So the training itself, I utilize the cloud. I could train on the laptop, but it would take 3 weeks, 2 weeks, 3 weeks. When I train in the cloud, it takes roughly a week and a half, give or take, from start to finish. What will determine the speed of training? A few things: how big the data set is, what compute I have available, and then also the resolution of the data set too. Higher resolution models will take longer to train, and also there's like an inverse relationship between like size of the model and resolution and performance. Even though the higher res models look higher resolution, when you're inferencing them in real time, you can't do it on a consumer grade hardware. And even if you could, you're getting like 6 frames a second, 7 frames a second. What I found from experience is that a 384 resolution model takes around a week and a half to train on like an A100. And allows me to inference it in real time using a gaming laptop, and do so at sufficient quality and speed. Whoever. Fake Connor Reeves. From experience, we found it's very successful and very impactful, because if you think about it, when you answer the phone, like you think it's your coworker, especially when it sounds like them, but B, used in conjunction with like caller ID manipulation. If it shows up on the caller ID that it's your own corporate number and it sounds like the person, right, you're not going to question it. So we found them to be very effective in doing like, for example, external breaches, like doing the call spoofing to like call the help desk to reset a password, or even impersonating people, within the organization and calling employees. And then most recently, not too long ago, we hooked them both up, the audio and video, and I jumped on a Zoom call and it was no questions asked. I was that person. Yeah, so what we're doing, we're inferring 2 models at once, and it's gonna take a little trial and error to properly calibrate the outputs and offset them appropriately so they both come out at the same time, right? So when I'm talking and moving, it takes a solid second or so for the face swapping to occur, and then timing the output to the audio to come out at the same time so they kind of match. So it does require a little bit of tweaking, but it can be done. But what I found is that in terms of like having a conversation with someone, the total latency is around 1 second, which is not noticeable at all. If anything, you can always say you're traveling or whatever. Internet sucks. So, next. Interesting. I didn't think we'd have enough time for this, but I guess we do, so I'll show you a video. Give me 1 second. Okay, do you mind changing the video back to my computer, please? So there's a few things that have stopped me in the past year from like doing the thing that I had to do. And I found them very effective. And the beauty of it is, for organizations, it doesn't cost them a single dollar to implement. You don't have to pay some third-party vendor $100,000 a month to do deepfake detection and collect all your video. You can do a few simple things. So for example, watch what happens when I hold my hand in front of my face. It looks like an exploding star. So the idea is, a lot of models aren't trained on obstructions right off the bat. So if you are having a conversation with someone and you see a water bottle sitting in the background, ask them, hey, hold the object in front of your face, right? 99.9% of the times, it'll cause the model and the inferencing to break, so you can easily spot the deep fake. That was a really good question. And another thing that's really effective is, let's say you suspect a deep fake, right? You think it's an impersonation. Instead of doing whatever the request is, say, hey, I'll call you back, right? Look at the person's real number in the corporate directory and call them back. Because although I could spoof your boss's number and call you, when you look up his real number and call back, I can't receive that call. Another thing that's really effective is tell me something only Brandon knows, right? having like a layer of multi-factor authentication before you have these like sensitive high urgency requests. A few years ago, my grandma got a phone call from someone claiming to be me and said, hey, Grandma, I'm in Mexico right now. I just got into a car accident. The police are here and they want a bunch of money, whatever. Can you send $4,000? She did. Had she asked a simple question saying, hey, yeah, I'll do whatever you want, but first tell me, where did I take you every weekend growing up? Because attackers wouldn't have been able to answer that question, that would have mitigated that attack. There was an example a few weeks ago, or a few months ago now, the CEO of Ferrari Motors, they had their voice cloned, and the someone high up in finance was targeted, and he was like, yeah, sure, I'll do whatever you want. However, tell me this first. What is the name of the book that I gave you last week? Because the caller couldn't answer that question, it mitigated and stopped that attack. Thank you, everyone.